This week in robotics was so insane that humanoid robots are now sprinting toward beating human world records, reading your brain before you make mistakes, and even powering themselves with living muscle. And no, that's not hype. That's what actually happened. In the next few minutes, you're going to see robots that can moonwalk on a soccer field, machines that explore without batteries, and one restaurant robot that turned dinner into complete chaos. But here's the real question. Are we watching the birth of a new industry, or a system that's still completely out of control? Let's break it down. First, South Korea just dropped one of the most athletic humanoids we've seen so far. The V0.7 doesn't just walk carefully like most robots. It runs, jumps, plays soccer, and casually throws in a moonwalk like it's nothing. That matters because most humanoids still look stiff and cautious. This one looks confident. Technically, it's built around a quasi-direct drive system with high torque motors and low gear ratios, which gives it faster response and smoother motion. It can already run at 12 kilometers per hour and climb steps over 30 centimeters. The next target is even more aggressive: faster speeds, higher steps, and ladder climbing. But here's the real shift. The team built almost everything in-house: motors, drivers, gearboxes. That means they're not just assembling parts. They're controlling the entire system. That's how you scale performance. And it gets deeper. The robot is trained using reinforcement learning combined with human motion data, which is why its movement looks natural instead of robotic. It can even handle uneven terrain using internal sensing alone. No cameras. Now here's where things get weird. A completely different robot, built for extreme environments, doesn't even rely on batteries. It's powered by wind. Literally, using a turbine and a multi-legged mechanism, it can move across harsh terrain like deserts or even other planets. Sounds simple, but it solves a real problem. Movement alone can drain up to 20% of a robot's energy. Remove that and suddenly long-duration missions become possible. The design is fully 3D printed, meaning parts can be replaced on site instead of waiting for resupply. That's a huge advantage in remote environments. But while some robots are becoming more efficient, others are proving we're still not ready. In a hot pot restaurant, a service robot started a dance routine and completely lost control. Plate smashed, food went flying, and staff had to physically stop it. Now imagine that happening next to boiling soup. This wasn't just a glitch. It exposed a bigger issue. Robots that perform perfectly in controlled demos can fail hard in chaotic real-world environments. That gap is still one of the biggest problems in robotics today. Now let's push it further. In China, researchers are training humanoid robots to play tennis using imperfect human data. That's a big deal because real-life data is messy. Instead of relying on perfect motion capture, they broke the game into smaller actions like forehands and footwork, then trained the robot to combine them. The result? The robot achieved a 96.5% success rate in returning shots across thousands of trials. And this leads to something even bigger: speed. Humanoid robots are now approaching human sprinting performance. Some prototypes are hitting around 10 meters per second. For context, that's close to elite human levels. There are even claims that robots could break the 10-second 100-meter barrier soon. That sounds insane, but the gap is shrinking fast. However, there's a catch. High-speed movement requires perfect coordination. Balance, force, timing, all synchronized with almost zero margin for error. And right now, robots still struggle when conditions aren't controlled. So while they're getting faster, they're not yet reliable. Now let's talk about something straight out of science fiction. Researchers built a swimming robot powered by lab-grown muscle that trains itself. Instead of external conditioning, the muscle tissues are designed to pull against each other, effectively exercising on their own. That self-training led to a massive performance jump. The robot swims over 3 times faster than previous versions and can be controlled using electrical signals or even sound cues like clapping. This is a completely different direction. Not just better machines, but hybrid systems that blur the line between biology and robotics. And while innovation is exploding, production is catching up fast. One company is now pushing toward manufacturing 10,000 humanoid robots per year. That's not a prototype phase anymore. That's industrial scale. This is where things get serious. Building one impressive robot is easy compared to mass-producing thousands reliably. That requires digital manufacturing, simulation, and full system integration. This is the moment robotics starts shifting from viral demos into a real industry. Now here's another leap. Scientists are developing robots that can read human brain signals and stop mistakes before they happen. Using e-data, the system detects error signals in your brain milliseconds before you physically react. That means the robot can pause, adjust, or hand control back instantly. In high-risk environments like nuclear cleanup or deep-sea operations, that could prevent catastrophic failures. And it doesn't stop there. A new fully compostable robot can perform over 1 million cycles and then break down safely in soil within months. Even its electronics are biodegradable. This solves a problem most people aren't thinking about yet. If robots scale globally, waste becomes a massive issue. This is one of the first real solutions. Finally, robotic hands. One of the hardest problems in humanoid design is replicating human hand dexterity. A new 5-finger robotic hand with 20 degrees of freedom is getting closer than ever. It's lightweight, compact, and uses back-drivable joints for safer interaction. That means better grip, more precision, and more natural movement. And this matters more than people think. Without hands that can manipulate objects effectively, humanoid robots are limited. Fix that and their usefulness explodes. So here's the reality. Robots are getting faster, smarter, and more capable at an insane pace. They're learning from messy human data, scaling toward mass production, and even merging with biology. But at the same time, they're still unpredictable in the real world. That's the tension right now. We're watching a technology that's clearly accelerating, but hasn't fully stabilized yet. And the biggest question is not whether robots will become part of everyday life. It's how fast that transition happens and whether we're actually ready for it. Because if this is what 1 week looks like, what does the next year look like?